Hello, I just wanted to showcase a very basic CUDA ray tracer I made. Code quality's not great, but it works, and I thought it was a pretty fun project. So, start up this application. You'll notice a bunch of fireflies and things like that. Um, and my BRDF isn't technically accurate, but as you can see, this is a real-time CUDA ray tracer with global illumination. You can see the nice soft shadows. Um, See the light bouncing on the back of this plane. I go over here, there's a glossy red sphere. You can see the plane. You can see there's light bouncing off of it. Um, there's the light source. And my BRDF isn't correct. Like, I'll show you in a second. This technically isn't size accurate, and it's due to the way I'm calculating my BRDF and things like this. It definitely isn't finished, but it's definitely a work in progress. I wrote everything from scratch. Intersection code, all that, sending everything to the graphics card, and holy moly, CUDA is the greatest library in existence. Let me demonstrate how my BRDFs are broken right now. I'm using next event estimation so I can resize my lights to be very, very, very tiny and very big and all of this, or really far away, and it won't really affect the quality of my render. So you can see here, this is what I was talking about. This is definitely not sized right. You can see the shadows are sharp, so it's definitely taking that into account, but this BRDF isn't being calculated right, which is fine. I mean, for the most part, it looks mostly accurate, kind of, but except for that. I have to fix that. It has to do with next event estimation. I haven't properly implemented multi-importance sampling, and my BRDF isn't the most realistic thing on the planet. I just mix between a perfectly diffuse and a perfectly glossy reflection, and tried to make that work, and it kind of works, but at the same time kind of doesn't because of that. But you can see there's a little light, it's going around in circles. And let me just demonstrate why CUDA code is the greatest thing on the planet, bro. So to give you an idea, a little bit of messy code here, but I'm gonna break it down real quick. I have this struct in which file is it? I believe I put it in my renderer file, or maybe my intersection file. Yeah. So I have this struct right here, which basically defines my objects. They have a transform, a color, roughness, light, and all of that. And in my main code, I have a array of objects, and I can just, add whatever I want to this array. I have to define a size, of course, but here's my beautiful array. I define my objects, right? And here's where CUDA is amazing, right? I take my object, make an array, or I make a array of objects, same thing like this one up here, but I just CUDA malloc, like I basically just call CUDA malloc, which malloc or allocates the memory on the graphics card. Of course, how many bytes it is, so size of object times num objects, right? And then when I want to move data from my CPU to my GPU, you just call it CUDA memcopy, right? Pretty standard stuff. Very nice though. Very simple. In any other like programming, graphics programming library, this would be not terrible, but also not easy. But yeah, very nice. Now that's on the GPU, and when I call render, it's literally right here. Number of blocks and threads. You could ignore those, but then I just tell it, hey, here's the objects that I want to draw to, and all the other parameters I want to give it, right? And also here's the image. This is literally just a unsigned char array, right here, right? Same thing, CUDA malloc. And then all I do is I take the data and just update the render texture and then display it. And in my renderer, let me show you how simple this is. This is my render function right here. It literally takes your image, view matrix, all that. You can in CUDA you can write functions like this, and this is like your kernel, and it gives you these special variables to tell you which thread you're on, and then you can just call functions. And then whenever you want a function that that's be able to run on your CUDA device, you just prefix it with underscore underscore device underscore underscore dunder, I believe they call it, or something like that. And then you just call the function, and it just works. So here I pass in my image and my objects. Of course, you have to, when you're passing stuff in CUDA, you can't pass in like things that like objects that have pointers, and of course arrays. You can't pass in like an std vector because that's allocated on the CPU. You could theoretically like allocate it on the GPU, or you could write like a struct that allows for dynamic allocation. but I didn't do that here. I just passed the size of the array right here. That way I can pass it to the graphics card. And then I just do my code like normal, and it just works. It's so amazing. Love CUDA. But yeah, same thing here. Just call the function. Here's the actual like ray tracing function. Same thing. You can pass arrays. And yeah, it's not too crazy. I use GLM, and as you can see, something very amazing about CUDA. Just works out of the box with most C++ libraries, unless they have like some sort of special device thing. Like this is completely C++, I believe, and because of that, it just works. It's amazing. You can also do crazy things, like I believe you can pass functions to your CUDA kernels as well, but I've messed around with it a little bit, but I haven't been able to get it working to the like way I want. But if I get around to that, I'm writing a raytracer, so I want to be able to pass like SDFs to the GPU, so that helps. But yeah, and then I just have a couple other things here, like I don't actually need this. I actually replaced this. I don't need this file anymore. It's just because I wanted operators for the float 3s, but I used GLM. And then yeah, here's my intersection code. Same thing, very simple. Just objects. Find what the object is. Have some data to transfer some hit data. And yeah, just basic intersection code I wrote. Not gonna lie, stole this one. Didn't feel like doing the math myself, but I did do this one. And there's just some code, some basic stuff. To handle. Also, something I must say, if you're going to write like one of these or like anything graphics wise, instead of trying to write a function that like for instance this intersection function that takes like a position and a radius of a sphere and blah 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 and yada yada yada, just make it based around 0 0 and make the size like a unit scale for all of your objects. Then you can just use like matrix transformations to scale, rotate, and all of that fun stuff to your object. Best way to do it, in my personal opinion. And they also CUDA also provides some amazing random things. If you've ever like tried to write a ray tracer on the GPU, you know writing random can be kind of frustrating because you have to like find a function and then implement it and find a way to pass a seed that's random enough that it'll converge but also doesn't have like weird problems. But yeah, CUDA just provides random libraries. They provide a bunch of stuff, really. If you're looking to like get into anything like using general purpose GPU, definitely mess around with CUDA if you have an NVIDIA graphics card. I know OpenCL is also pretty good and that works on all of them. And if you really want to make it work on everything, use Vulkan, but holy moly, Vulkan is very, very verbose. I think the hello triangle example is like 1,000 lines. Like, oh my god, but yeah. HDR loader, I haven't written this yet, but I have written one of these before. Good fun. Definitely want to implement that at some point. But yeah, that's all I basically have. CUDA is amazing. And if you have the opportunity, I definitely mess around with it. But yeah, CUDA ray tracer. I know I didn't show much of it, I'm not gonna lie. Definitely want to work more on it. Also, I use SFML for actually like implementing or creating the window because I didn't feel like using raw and GL. You could have like GLFW and all that, but you know. But there you go. Realtime. I have a NVIDIA RTX 3070 Ti. I'm not using the actual RT cores, just using the straight up CUDA cores. So this would work on something like a 1080, right, or something older. But 3070 Ti, and I get like 8-9 milliseconds, something in that neighborhood. Then again, this is a really simple scene. I think most GPUs could probably render something like this. It's really simple. It's like, what, 2 spheres and 2 planes, so. But, you know, pretty cool. Pretty fun. Yeah. Thank you very much for watching.